Hello and welcome. Today we're going to investigate the relationship between force and change in momentum. We call this impulse, and we'll look at that just now. So we all know that Newton's second law says that the resultant force is mass times acceleration. We also know that acceleration is equal to the final minus the initial velocity over the time, or we can call it the change in velocity over the time. So since acceleration is in both formulas, what would happen if I substitute that into there? So if I have the change of velocity over time, then I'd still have my mass and my resultant force. What do you notice? Okay, where have you seen mass times change in velocity before? Okay, gave it away in momentum. So since mass times change in velocity gives me change in momentum, therefore the change in the momentum divided by the time is equal to the resultant force. So this is the relationship between change in momentum and force, and why, if the resultant force is negative, I will have a negative change in momentum. Both force and momentum are vectors. Time is a scalar, okay, and the momentum will have the same direction as the resultant force. So when we rearrange this and we say that force, or the resultant force, times with the time is change in momentum, we call this quantity force times time. So we can also call it change in time, okay, because it's the time interval. So force times time is what we call the impulse, and impulse is equal to change in momentum. Okay, so we call this quantity force times time, impulse. We measure it in Newton seconds. We know that we measured this in kilogram meters per second, and these two units are actually equal or related to each other. So change in momentum can be measured, well, change in momentum is the same as impulse. Change in momentum can be can have this formula, a unit, or that unit, because it's the same quantity that we're calculating. Okay, so if we look with momentum, an impulse, a change in momentum is created by an impulse. So we need a change in momentum, okay? To cause a change in momentum, we need an impulse. We need a force, and we need that force to be acted out over a period of time. When a force is applied for a time period, a bat is used to change the momentum of the ball pitch. The ball coming here has a positive velocity, going away has a negative velocity. So something caused its velocity to be changed, and there's the force, and it acted on for a small period of time. So if we move on, okay, impulse is also equal to the change in momentum. So here on the left we have what we call impulse, here on the right is what we call change in momentum, and they are related to each other. So since impulse equals the change in momentum, the unit can be the standard impulse unit, Newton's seconds, or the unit for momentums, kilogram meters per second. Both units can be broken down to be to the same derived unit, since a Newton is kilogram meters per second squared. Okay, so let's quickly look at it. Why is this important? If we look at the fact here, so we know that impulse is equal to the change in momentum. Both these cars have the same final and same initial velocity, so both of them will have the same change in the momentum. So the left hand side of the equation, the change in momentum is the same. What is not the same is the time that the force acts. So since the top car does not crumble or smash, the period is a very small period. But at the bottom car, we can see the car crumbles, extending the time of the impact. So let's look at what does this mean. Okay, for both cars, I've got the same change in momentum, the same mass, same final, and the same initial values. So that stays the same. Okay, the time, well, let's quickly look at it. If 6 times 1 gives me 6, and I still want an answer of 6, because my answer needs to stay the same, but I increase this value, what's going to happen with the other value? It's going to decrease. So as the time of the impact increases, the force is distributed over a longer period of time and the force decreases. Now, what is the application to this? This is the reason why we use airbags in a car. Because the moment you hit that airbag, the airbag extends the period of time, okay, through which you are in contact or your motion, and it decreases the force. Okay, this is why cars crumble. Okay, when the newest cars, and you can especially see Formula 1 cars, they are made to deteriorate in order to extend the period of time of the collision so that the force is decreased. Okay, the old cars, you could drive off a cliff and the car would almost literally look the same. Where the new cars, you hit a squirrel, the squirrel refuses medical attention, but the car is completely wrecked. Okay, the newest cars are built to crumble so that they extend the time, decrease the force. Okay, another example of this, if you've ever played cricket, okay, or if you've ever catched an egg, you don't just simply catch the egg. You catch it and you like bring it down, okay? So there's like a motion where you bring it in, okay? And that extends the time that you use for the force, okay? So longer time, smaller force, and then the egg will not break or the cricket ball will not hurt your hands. Okay, ballerinas or people, they don't jump like this, okay, with stiff legs. They jump and they land and they bend their legs. So even I want you to try and just jump off your chair with stiff knees, and you will feel it's very painful. But if you jump and you bend your knees, okay, you are increasing the time through which that force is acting, and therefore it's less painful. Okay, so impulse, very important concept to understand. Impulse is force times the time, and it's also equal to the change in momentum. So this brings us to the concept of cushioning. Any form of cushioning gives us more time and less force. So impulse is composed of force and time. Padding increases the time for a force, and the force is applied and therefore decreases the amount of force. this decreases the force and can lessen the impact of that force. Okay, let's look at an example. How much force is required to stop a 0.145 kilogram baseball traveling at a time of or speed of 44 meters per second in a time period of 0.020 seconds? Okay, so we see here, here they used I for impulse. Impulse is the change in the momentum. So impulse consists of force and time. Change in momentum consists of mass, final velocity minus initial velocity. We take the time over to the other side because we want to calculate force. So we divide with time on both sides. Time ends up here. We substitute the values. And remember, it goes from 44 meters per second to 0 seconds. It stopped. Okay, so in order to stop something, I have to have a opposing force. And therefore, I get a negative answer. That negative answer tells me that the force was opposite to the movement of the ball. So the ball is going in one direction, and then I have to apply force in the opposite direction to the ball's motion. And therefore, we have a negative 319 Newton. Okay, so what does this formula do? It helps us to calculate the force if we have the change in velocity, the mass, and the time. It helps us to calculate the impulse, okay, if we have the change of momentum. So if I've got the mass, the final initial velocity, I can calculate the impulse, okay. It helps us to calculate if I've got the force and I have the time, the force. So if I want the change in time, and I know the change in momentum, the mass, and the initial and final velocities, and I have the force, I can calculate the time for which the force was acted upon. Okay, so there's a few things. Just remember this quantity is called impulse, and change in momentum is mass and final minus initial velocity. So we're equating two quantities. We're equating change in momentum to impulse. Impulse has this formula, change in momentum has that formula, and they have equal units, and now we can use these quantities to calculate force or time or the change in velocity or the mass. So if I have the force and the time and the mass of the object, I can calculate its change in velocity. If I have the change in velocity, the mass, and the time, I can calculate the force. Or as we've seen here, if I've got the mass, the velocity, and the force, I can calculate how long was the time that it was impacted by. I hope you understand this session. If you've got any questions, feel free to let me know, and then we'll take it from there. Thank you very much.